The last part, we were hopeful that things are going to get easier as we go forward. So spoilers, they don't. For 26, which alcohol will react with an acidified solution of potassium dichromate to produce a ketone containing 6 carbon atoms? So all of these alcohols, primary alcohols are going to get oxidized to form aldehydes. Primary alcohol gets oxidized to form an aldehyde. The aldehyde can get further oxidized to form a carboxylic acid. No more space for some reason. Okay, whatever. Carboxylic acid. Secondary alcohol can get oxidized to form a ketone. Secondary alcohol gets oxidized to produce a ketone. So let's go through all of them one by one. Carbon, 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 carbon. 2,2-dimethyl butane 1-ol. There is a carbon over here, a carbon over here, and OH over here. This is a primary alcohol. It gets oxidized to produce an aldehyde. The H goes away. So this is not going to form a ketone out of our options. Let's do the same thing again. We have 2-methyl-pentan 3-ol. So there is a pentan, there is a methyl, there is a 3-ol, which is going to get oxidized to form a ketone. So this ketone contains 1, 2, 3, 4, 5, 6. This matches our conditions. 6 carbon atom with a ketone. So this is probably our answer. Let's look at the other options just to be safe. We have 3,3-dimethyl-pentan 2-ol. So CH3 over here, CH3 over here, pentan 2-ol does oxidize to give a ketone, but there are 7 carbon atoms over here. 1, 2, 3, 4, 5, 6, 7. So this does not satisfy our conditions. The last one is 3-methyl-pentan 3-ol. So we have 3 methyl groups. We have the pentan chain along with an OH and a CH3 group in the same carbon atom, which makes this a tertiary carbon alcohol, which does not get further oxidized. So this is not going to be oxidized. The only answer available is B. Number 27. Which statement about butanone is correct? What is butanone? Butanone is a 4 carbon atom that contains a ketone group. So carbon, 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 carbon. The oxygen is going to be either in the second or third carbon, making both of them the same thing. So this is butanone. Can be dehydrated by concentrated sulfuric acid to give CH2, CH, CH, CH2. This would have been true if it were an alcohol, but this is not. This is a ketone, so this is not going to be the answer. Also, there's going to be 1 double bond that's formed, not 2, unless it was a diol. Butane gives a positive result with Tollens reagent. Aldehydes give a positive result with the Tollens reagent, so this is obviously not going to be true. Butanone reacts with HCN by an electrophilic addition mechanism. The CN is a minus ion, which is attracted to the del positive carbon center. So this is nucleophilic addition, not electrophilic, so this is wrong. Sodium tetrahydroborate reacts with butanone to produce a chiral carbon. A chiral carbon is a carbon which has 4 different functional groups attached to it. 1, 2, 3, 4. So let's see what happens when the sodium tetrahydroborate reduces the ketone. It results in the formation of an alcohol, a secondary alcohol, hydrogen group attached here, CH3 group attached over here, and a C2H5 group attached over here. All 4 are different. This is a chiral compound, so the answer is going to be D. Number 28. Ethanol CH3CHO is used to make product R in a 3-stage synthesis. So let's see what exactly happens in these reactions. CH3CHO reacts with sodium cyanide to produce CH3. C, the O group, this used to be a double bond O and an H. This gets replaced by an OH group on top and a CN group at the bottom. This is called a hydroxynitrile. So we get product P, which is a hydroxynitrile. When it is react with the sulfuric acid, the cyanide group gets converted to a carboxylic acid. So we now have C double bond O, COH. So this now has an alcohol group and a carboxylic acid group. These two will now react together in the presence of sulfuric acid to form esters. The OH is going to react with the carboxylic acid part, and the alcohol is going to react with, the carboxylic acid is going to react with the alcohol part. So let me draw it in a clearer space. Let's see what happens. We now have C, 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 O, OH. Let's make this like this, OH. I think it would be better if I draw it like this, sorry. So COOH. And we have another carbon over here, carbon, carbon, carbon. So this is going to want to react with yes. So let's write like this, C, C, C. Let's make it an OH over here, and the double bond O, OH over here. So both of these things are the same. These two react together. These two react together. Two water molecules are left, are condensed out of the equation. So we now are left with oxygen reacting with this and an oxygen reacting with this. So the final compound has 6 carbon atoms, C6. It has 4. This has another hydrogen, 5, 6, 7, 8. So 8 hydrogen atoms over here, 4, 5, 6, 7, 8. And oxygen atoms, 4. There are 4 oxygen atoms, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, and 6 carbon atoms. So C6H8O4. We are looking for the empirical formula, so let's simplify this, C3H4O2. So this is the answer we get. The answer is B. For number 29, the ester ethyl butanoate can be hydrolyzed using an excess of dilute sodium hydroxide solution. Which substance is a product of this reaction? So let's first draw it. 2 carbon atoms, ethyl, so there is hydrogen, hydrogen, hydrogen. There is a hydroxide group over here, so there is going to be an O, and the carboxyl group reacts like this. So butanoic acid gets converted to butanoate, so carbon, carbon, carbon. Everything else is hydrogen atoms. So this is our reaction. Now when sodium hydroxide is added, this becomes ethanol, so H is added here. And this entire thing, the rest of it, becomes sodium butanoate. So what we have over here is an ONA group. I hope everyone can understand. All right, let's just erase this part. So we have an ONA over here, and we have an ethanol over here. So these are our final possible products. So the only one that matches here is A. The others do not match, so these are all wrong. So our answer is A. Number 30, the infrared spectrum of an organic compound is shown. Which compound could give the spectrum? For this, I'm going to need the data booklet, which I'm going to bring out now, so give me a sec. So we have 2 peaks over here. The first peak is in this range. So this is a strong peak. So let's see what corresponds with this one. 1670 to 1740, we have an S group, 1640 to 1690, 1710 to 1750. The exact location is kind of hard to decide. This is definitely 1700 plus. So between 1710 to 1750 or 1650 to 1740, that range. So the guaranteed thing is that this has a CO group. That's all we know. Then there is a weak peak, there's a small peak over here at 3000. This can be alkane group or alkene group. So this is between 2850. So let's, if I draw a straight line over here, this falls in the 29 to 3000 range, between that. So this has a high chance of being alkane. So So let's see which one follows this. A has CH3, CH2, COOH. Now it has the CO group, it has the CH group, but it also has an alcohol group, OH group, which is supposed to have another peak in the 2500 to 3000 range, which is going to supposed to be very broad. So it should have had a peak like this, something like this. It should have been very broad. So I don't draw very well, so excuse me for that. So this is probably not going to be the answer. We're just going to cut it out and see if there's a better option available to us. The next one is CH3, CHOH, CH3. So let's see, carbon, hydrogen. We can straight away see that this has the OH group. This does not have a CO group, so this is definitely not going to have the answer. So this is out of our options. The next one is CH3COCH3. So it has the alkane group, it has the aldehyde, the ketone group, and it has the alkane group again. So this one seems to be following our conditions. The last one is, sorry about this, the last one once again is CH3COCH2OH. So there is a carbon hydrogen group, a double bond O. There is hydrogen over here, there's an OH over here. This OH is not accounted for in our infrared spectroscopy, so this is not going to be our answer. The most likely answer is going to be C, so this is what our answer is going to be. The others do not match. We are going to cover section B in the next part, hopefully, inshallah. See you then. Goodbye.